Hello everybody, so today I will be explaining to you on chapter 8, which is on physics of matters. So there are several subtopics. I think there are 4 subtopics if I'm not mistaken. Yeah, so there are 4 subtopics in this chapter, but only a few subtopics that has calculation. So the first few part of this chapter is basically on the theoretical, on the theory. So the first subtopic is on stress and strain. So in this subtopic, you have to be able to distinguish between stress and strain for tensile and compression force. Next, you have to be able to analyze the graph of stress against strain for a metal under tension, explain elastic and plastic deformation, and lastly, you have to analyze the graph of force against elongation, ataupun sometimes it is called as extension, for brittle and ductile materials. Okay, so stress, the symbol is sigma. So it is defined as a force that is acting per unit cross-sectional area. So it has the SI unit of kilogram per meter per second square. Okay, ataupun kamu just boleh letak Pascal ataupun Newton per meter square. Okay, so whichever is easier for you to remember lah. So the formula is given here. So that is basically the formula for stress lah. Where F is the force perpendicular to the area, okay, to the cross-sectional area. So strain, on the other hand, has a symbol of epsilon. So it is defined as the ratio of change in length to the original length. So it does not have any unit. Why did I unit? Because if this is m, they cancel each other. Okay, so that's why they don't have unit. So delta L is the amount of either it elongates ataupun it is compressed lah. So this is compression, this is elongation. So this is the value of delta L, this is delta L untuk compression lah. Okay, so L naught is basically just the original length. Ataupun di sini E here is basically telling you the elongation lah. So after it is being stretched out here, the extension is just this small part here lah. Okay, so stress and strain. So the amount of stress that we apply to an object will determine the level of strain the object would experience. Okay, so strain is the amount of deformation an object can undergo due to stress. Bukan can undergo, it is the amount of deformation an object undergoes under stress ataupun due to stress. So it depends on how the force is applied. So how the force is applied depends on kejap. An object can undergo different types of stress and strain, depends on how the stress is applied lah. So untuk syllabus kamu, kita just focus on compressive stress and strain lah. Okay, so when an object is under tension, for example here, so this is a apa tu nama dia, under tension now, so it is being stretched out, so it experiences an increase in length. Oh, okay, so there's an error here, it should be an increase in length, not end. Right, so next, for example, if you are squeezing a rubber ball, you are actually creating salah baca. For example, a rubber band, when you stretch, it will experience tensile stress and strain. Kan ni rubber, selalu kalau kita mau elastik kurang, kita tarik dia sampai sini kan. So what this rubber band is experiencing is basically tensile stress and strain lah. Okay, alright. Next, untuk compressive force pula, when an object is compressed, it is undergoing a decrease in length. Okay, so untuk tensile stress tadi, they undergo an increase in length. Untuk compression, dia punya length decreases. Okay, alright, sorry everybody, I'm actually editing the notes while I'm recording the video. Okay, so next, so basically all objects can experience tensile and compressive stress and strain, but not all object would react to that stress to the same degree. Okay, apa maksud dia? Kita tengok pula the graph of stress or strain for a metal under tension. So, ni untuk metal under tension lah. So basically at point A, from point O to point A, this is the proportionality limit. So basically kalau dia kena stretch sampai point A je, dia masih boleh go back to its original state. Okay? And then from point A to point B, dia masih lagi elastic but it is no longer linear. Okay? So dia tidak linear sudah sekarang ni. Dia start to curve sudah at this point. From point B to point C pula, from point, so basically this part here, this part of the graph is what we call as the elastic deformation lah. So if the stress is removed, it will still continue to, it will return to its original shape ataupun size. Tapi after point B tu pula, we call it as plastic deformation. So this is where permanent deform occurs due to stress. So that is from point C, D to E lah. So B is the elastic limit, C is the yield point, D is the point of maximum stress. Point of maximum stress is the point where before it starts to go to its breaking point, where it is at point E. So bila dia sudah point E, dia sudah break. Ataupun kalau glass, dia pecah lah, macam tu. Alright, let me just explain it to you roughly, because you can read it as well. I just have to kind of just go through it you together lah. Sebab, yalah bahkan lecture video pula. Okay, so elastic deformation. So we just refer to the graph, back to the graph lah. Time kamu baca ni. So it occurs when an object can return to its original length ataupun size after being distorted. So that is from point O to point B lah. So from point O to point A, we can see that the stress increases linearly with strain. See, it increases linearly with strain until point A. Okay, right? And then the straight line graph obeys Hooke's law, which states that, states that below the proportionality limit, the restoring force is directly proportional to the extension. So this is how we come up with this equation here. That is based on Hooke's law. So the negative sign here indicates that the restoring force would be in the opposite direction of extension lah. Restoring force maksudnya dia akan try to restore it to its original position ataupun original shape, original length, semua tu back to its original. So also, of course it will go against the extension, alright? So that's why ada negative di situ. Point B pula, this is the elastic limit of the material. So anything beyond this point, the material would be permanently stretched and will never regain its original shape. Okay, shape and length. So if the stress is removed, the material has a permanent extension lah. Okay, so for example, kalau rubber band kamu di sini, lepas tu after limpas the point B, kamu stretch dia sampai begini beyond its proportionality limit, it would stay this way. It wouldn't go back to its original size and length. Okay, so that is for elastic deformation. Let's look at plastic deformation pula. So it would occur when an object has been deformed beyond its elastic limit. So at this stage, this object can be extended by a large amount with a small addition of force lah. Okay, so dia tiada boleh force yang terlampau besar at satu point tu, nanti dia akan terus pergi point E. Okay, after the force is removed, the object cannot regain its original length ataupun shape. Point CD is known as the plastic deformation. So point C is the yield point where it marks a change in the internal structure of the material. So that's why dia tiada boleh go back to its original shape lah. So the layer of the atom slides across each other, resulting in a sudden increase in extension, and the material will thin uniformly. When stress is increased, strain will increase rapidly. That is point C. Point D pula, this is where the stress on the material is at a maximum, so it is known as the breaking stress. Okay, so it is also known as ultimate tensile strength, UTS. So anything after this point, the material will thin out and necks are formed. So point E pula, this is the point where the material would break ataupun fracture. Maksudnya neck is form is contohnya kalau kamu ada rod begini, after you pull it, it will form something like this before dia break. Okay, right. Something like this lah. Okay, so this is just a graph of stress strain for various materials. So ductile materials would undergo plastic deformation before breaking. Brittle wouldn't undergo do not undergo ataupun show very little plastic deformation before breaking lah. Glass, bone semua ni. Okay, so this is the example for this one, the graph for this one. This is basically for this one. Alright, yeah, so that is on subtopic number 1 of chapter 8.